Sampai ayat 2 kan salah tadi.
Can we start?
Yes, Doctor.
Okay, Assalamualaikum warahmatullahi wabarakatuh and good afternoon to all of you. So thank you very much for joining my lecture today. So before we are going to start with new topic, ODE IVP. So I would like to ask you, how about the project? Can you complete by this week and submit in e-learning? Any problems? So I hope you can complete by this week, yeah?
Yes, Doctor, we can.
Okay. Then after today class, I will assign you another project. Okay. Project number 2. So this project must 2 people. Okay, must 2 people. Now, before we discuss about the project number 2, I start with topic IVP first, yeah. Okay. Can you see my slide?
Yes.
Okay, now this is the second last topic, ordinary differential equation for initial value problem. After finish IVP, so our last topic for this semester is boundary value problem. So partial differential equation, we agree for this semester we not teach all students because we omit to give project 2 using PDE. Okay, project number 2 until BVP only. Okay, what is the outcome for this topic? Okay, by end of this topic, students are able to solve the governing equation by using appropriate numerical method to the system under investigation. Okay, you are able to solve any governing equation using IVP method. Okay, and then second outcome, students are able to analyze the validity and accuracy of the numerical solution. So when you solve the governing equation, you know how to produce the error. Okay, comparing the method and then produce the error value. What kind of method give good accuracy for our problem? Okay, initial value problem and boundary value problem. So this is two topics. For initial value problem, how can we identify this is IVP and this is BVP? Okay, this one is IVP and this one is BVP. Okay, if our equation, only has a value of the dependent variable for their derivative known as initial value, of the independent variable only mention about the initial condition. Okay, if our governing equation problem mention about only initial condition, not specific, only use initial condition, that is initial value problem. For example, dy over dx is equal function xy with initial condition y x naught equal y naught. Only initial condition. Okay, only initial condition. So, only initial condition falling under IVP. Okay. Second one, boundary value problem. How can we identify this is a boundary value problem? If the dependent variable or its derivative are known at more than 1 point, okay, from 2 and above of the independent variable is the differential equation falling under boundary value problem. Example, okay, delta squared y over dx squared, okay, even though this is a second order, first order also can, okay, dy dx, okay, equal function xy. Okay, either first order, second order also can identify as boundary value problem if, if the derivative are known at more than 1 point of the independent variable. With boundary condition, first given the initial one, the second one is end condition, or we call as the boundary condition. Initial, okay, end condition. So 2 and more condition, that is boundary value problem. Okay, please understand, yeah. Okay, as the introduction for IVP, okay, why we need to learn IVP? Because it's easy to solve the homogeneous equation of ODE and easy to analyze the validity and accuracy of ODE compared to ODE BVP. Okay, compared to BVP, of course, IVP more easy than BVP. Okay, so we understand that ODE is ordinary differential equation. Okay, when someone asks you what is ODE, ODE is ordinary differential equation. Okay, function for IVP only involve one independent variable. Okay, when involve one independent variable, we call as ODE. When involve more than two independent variable, we call PDE. Okay, so we not touch for PDE yet. Okay, this is only ODE. When the parameter effect to the dependent variable, 2 and more, that is BVP. If only one, IVP. Okay, so the example of ODE such as Newton's second law, Fourier's law, Fick's law of diffusion, okay, and so on. Okay, Newton's second law, okay, we use to compute velocity of the falling mass m as a function of time. Okay, that we always use dv over dt equals g minus c over m multiply v. Okay, we also know that g is the gravitational constant, c is drag coefficient, v is unknown function, okay, and its derivative dv over dt. Okay. We also understand that from this equation, we can call V is dependent, T is independent variable. When function involve one independent variable, we call as ordinary differential equation. When function involve two or more independent variable, we call as partial differential equation. Okay, this is sample. Newton's second law, so this is the equation. Okay, Fourier's Hicks law, this is the equation. Fick's law, this is the equation. Okay, and so on lah. Okay, so basically, the numerical method, okay, to solve ODE, we always use dy over dx. dy over dx is actually function, okay, okay, effect from x and y, where we understand that for every increment, okay, for every increment, it means that new value, okay, new value happen from old value plus, okay, plus slope multiply step size. Okay, in order to solve ODE, okay, we must produce new step size. So new value, which means new step size, is equal old value plus the value from multiplication of slope and step size. Okay. So we transform this statement into mathematical form. Okay, so mathematical form can be written as new value is yi plus 1. Old value is yi. Slope is phi. Step size is h. Okay, so this is also same as the previous topic. Okay, same as the previous topic. Why? Because for any increment, we always use I plus 1. Am I right? Okay, and then all value, we always use yi. It means that initial. Okay, initial. Okay, and then phi is slope estimation. This method is known as one-step method. Okay, one step increment, yeah? Okay. So how can we solve ODE IVP? So two methods that I need to introduce you. Okay, first method we call as Euler method. The second method we call as Rankata method. Okay, it's not too hard, easy. Okay, easy to solve any kind of problem. Okay, first have a look the Euler method. Euler method is the earliest technique developed for solving the ODE and simple technique. Okay, in general, we know that the ODE is dy over dx is equal function of x and y. Okay, based on the Taylor series expansion, we also understand that yi plus 1 is equal yi plus hyi prime plus h power of 2 over 2 and so on. Okay, and so on. So we continue this process until we can determine the error term. Okay, the error term. When we increase to the high power, so the error term can be negligible because it becomes a very huge value. Okay, very huge value. Therefore, we can conclude that for the Euler method, we use the general equation such as yi plus 1 equal yi plus h function xi yi for every I iteration from 1, 2, 3 up to the n value. Okay, so we also understand that the first derivative provides a direct estimation of the slope. We also understand that slope is the function of xi, yi. Slope is the function of x, I and yi. For every increment of I, it will give different slope. Okay, give different slope. Okay, and then we do the substitution, okay, for the slope, okay, in Taylor series. Therefore, we can conclude that the general equation for the Euler is yi plus 1 equal yi plus function xi yi multiply h. Okay, yi plus 1 is a new point, yi is the old point, fxi yi is the slope of the problem, and then h is step size. Okay, so please highlight this equation for Euler method. If you use a module, please check this equation and then highlight. If you use textbook, please use this equation, highlight. Okay, highlight in your textbook. Okay, equation 10 represent the Euler method. And or we can also use Cauchy-Euler term. Okay. Any question before we proceed for the example 1 using Euler method? Any question? Okay. So now this is the example 1. Okay, Fakrul. So now we understand the general equation for the Euler. Fakrul?
You get it. Hello.
Fakrul? Asrul? Asrul? Tak abahlah, mak reply. Asrul? Asrul? Everyone don't have mic. Ki Hui Fong? Ki Hui Fong, Lim Hui Jin, Muhammad Hazmi, Nakib.
Yes, doctor.
Yeah.
Okay,
Doctor.
Lim Hui Jin. Nakib ya, Lim ya.
Yeah.
Okay, Lim.
Yeah.
Okay, now we will go through the example 1 Euler method. So based on this equation, dy over dx equal negative 2x power 3 plus 12x power 2 minus 20x plus 8.5. Okay, if we see this equation, so it's actually what kind of value? Apa Lim? Kita nak masuk equation ni di mana?
Dalam tadi itu equation y I plus
Equation
1.
mana? So we have yi plus 1 equal yi plus function xi plus yi multiply h. Equation ni sebenarnya nak masuk ke mana?
F x y f bracket x comma y comma.
So this equation. Okay, this equation is actually yang ini kan?
Yeah. Yang f tu
Okay, betul. Okay, betul. Nakib. Okay, Nakib. I want to ask you. From x equal 0 to x equal 4 with step size of 0.5. Apa ni? Macam mana kita nak transform dia jadi mathematical form?
H dia 0.5.
Okay, h 0.5. Okay, so x equal to 0 tu apa?
Initial condition dia.
Okay, initial condition. This one is initial. Okay, x equal 4.
X sampai 4 tu step size yang 0.5. Step size 0.5 tu X sampai 4 saja.
Okey, betul. So ada berapa kali ni? Macam ni kita nak tahu ni berapa kali kita nak ulang.
5.
Macam mana 5 tu? Macam mana boleh jadi 5?
X equal to 0 tu yang iteration yang pertama. Sampai X equal to 4.
So maksudnya X1 ini okey 0.5. X2
1.
X3
1.5.
lagi.
X4 2.
Berapa kali ni?
5 kali.
Okey, 2.5. X6. Berapa kali?
8.
Ni silap. So how can we make this conclusion? Kan awak ingat tak ada satu subjek, satu topik tu kan delta X B minus A over
H.
kan, H. Okay, ni delta X. So kamu masih guna itu dah juga. 4 minus 0 bagi
0.5.
dapat berapa? Dapat berapa kali?
Sekejap.
Belum dapat lagi daripada LSTM. Tapi awak boleh keluar di LSTM.
8.
8. That is the easiest way how can you know lah.
Boleh siap dan sekarang.
Okay, so 8 kali ya, 8. Okay, so how can we transform the initial value problem? Initial value problem. Initial condition at X equal to 0 is Y equal to 1. Macam mana kita nak tulis mathematical form dia? Azim. Azim? Raymond. Raymond. Richmond. Richmond. Fatin. Rizwan Yaakob.
Doktor.
Baihong. Rizwan.
Doktor.
Okay, Rizwan. How can we transform the initial condition at X equal to 0, Y equal to 1?
Transform jadi apa maksud doktor? Transform to Euler punya formula ni yang yi plus 1.
Okay, you kena buat dia initial condition punya term dulu. Initial condition punya term seperti sebelum ni.
Yx not equals to y not.
Ya. Ni. You must write this one. Compulsory. You must write this term. Okay? Because from the statement, you must transform to the mathematical form. Okay? As I mentioned to you, from the statement of ODE, IVP, okay, ODE IVP, dia mention new value equal to all value plus slope multiply step size. So they transform to the mathematical form to become yi plus 1 equal to yi plus ph. So initial dia pun kena transform to the mathematical form. Mathematical form ni macam mana?
Yi plus 1.
Y
not.
Macam ni pun boleh.
Okay.
Atau or you can put yx naught sama dengan 1.
Oh, okay.
Okay, this is the mathematical form. Okay, mathematical form. So this is compulsory that all students must mention, okay, during test. Question, very long question or very long problem statement, then you need to write like this, mathematical, mathematical. So after you understand this one, you transform to this one, and then this you transform. So how can we start? Okay, how can we start to solve the problem IVP using Euler method? Okay, sekarang kita tengok. we understand that we need to iterate 8 times. Okay, 8 times. So first iteration pada at x equal to 0.5. Why 0.5? Because step size 0.5. From 0 to 0.5. From 0.5 to 1. From 1 to 1. Okay, 1.5. Okay, so kita start dengan x equal 0.5. So kita guna equation yang ini ya. Okay, so kita dalam mind kita, okay, dalam minda kita, we always use general equation for Euler. Yi plus 1 equal yi, okay, plus phi h. Okay, phi tadi fxi yi lah. So fxi yi tadi equation yang diberilah yang ini. Okay. So you tengok. At x equal to 0.5, so y 0.5. Because y 0.5 because I dia dah tambah satu langkah. Okay, I plus 1. So it means that I plus 1 step. So 0.5. So y 0.5 is equal y naught. Y I plus 1 is equal yi. Yi is all value. All value. What is the all value? Dalam case ini y naught. What is the value for y naught? Richmond?
Y naught is 1.
This one ya. Kita tahu y naught is 1. So please insert value 1. Value 1. Okay, plus phi multiply h. Phi yang mana? Yang ini kan? Ini phi. So phi kita adalah dy dx. So dy dx nya adalah ni. Minus 2x. X adalah 0.5. Masuk saja 0.5 plus 8.5. Ni. I'm sorry, not 0.5 because this is yi. Ingat. This is f xi yi. It means that I means all value. All value. All value is 0, 0, 0. And then solve this one, multiply 0.5. Why 0.5? Because 0.5 is step size. Step size of 0.5. Solve this one, you obtain 5.25. So 5.25 at y x 0.5. So you continue process for x equal to 1. Okay. So x equal to 1 is new point. New point. So the old point is y 0.5. So y 0.5 is 5.25. Masuk 5.25. And so on. You repeat it again, calculate, and then you obtain y at x equal to 1 is 5.875. Okay, 5.875. Okay, and then you repeat again 1.5 to 2.5. Okay, got it? 1.5 to 2.5, 3, 3.5, and 4. Okay, and then you complete all the y value. So you always need to understand that what you calculate and what you repeat is for Euler method. So put here as Euler method. How can you produce y true? Y true is only directly from this value, integrate. Integrate. Okay, so you integrate lah. Integration of dy dx from 0 to 4. Kan? You integrate, you boleh dapat y true value. Masukkanlah x kosong, 0.5 and so on. So you dapatlah value ni. How can you produce error? Okay, ini tolak ini bagi ini. Ini tolak ini bagi ini. True minus approximate divide true. So you dapat this error, this error. Okay, any question regarding Euler method? Any question regarding Euler method? So Euler method is the easiest way when you want to solve ODE IVP. Okay, easy. Even though for test 2, student also always use Euler method. Always use, because it's fast to calculate. Any question before I proceed to second method, branch kata. Tak ada kan? So the branch kata method do not require the derivative of fx xy but produce result equivalent in accuracy to the higher order Taylor series formula. Advantages. Okay, using branch kata required only one initial point to start the procedure. Disadvantages. Branch kata requires several evaluation of fxy for each step of integration, which can them slower than others method, but they accurate. Okay, branch kata more accurate than others method. Okay, for branch kata, I need to introduce you until fourth order of branch kata. However, during test, it is up to student. Either you want to use branch kata or Euler method. Okay, branch kata order number 1. Branch kata order number 1 is actually same as Euler. Can be seen to be same as Euler. Same way. Okay, same way. Ingat, branch kata order 1 same as Euler method. Okay, and then branch kata order 2, the different only for k value. Only for k value. Okay, to order branch kata, you must need to find k2. K1 is equal function x1, y1 same as Euler. Same as Euler. Okay, so no problem. K2. K2, you must have specific function. Function xi plus p1h, comma y plus q11k1h. How can we deal all this value? Okay, so p value and q11 value given to student. Okay, if we want to use branch kata order 2, then we give p1 value and q11 value. So branch kata second order is actually, okay, start with the derivative, okay, very long derivative, and then continue with substitution, all those equation until the end of the branch kata order 2. They conclude that for P1 is half if A1, A2 and A1 is 1. Okay, if A1 equal A2 equal 1. Okay, then P1 is half, Q11 also half. Okay, we now have 3 simultaneously equation containing 4 unknown constants, hence they no unique solution. However, assuming a value for one of the constant, we can determine the other 3. Consequently, there is a family of second order branch kata method rather than a single version. Rather than first order branch kata lah ni. Okay, first order branch kata. Okay. Therefore, second order branch kata, basically, in general, we use yi plus 1 equal yi plus a1k1 plus a2k2 multiply h. By giving the value a1 and a2, then you can produce k1 plus k2. Okay, if question give the value a1 1, a2 1, so y1 plus k1 plus k2 multiply h. Okay, if branch kata second order with the a1 value is half and a2 value is half, then the second order branch kata value become y1 plus 1 equal y1 plus half k1 plus half k2 multiply h. Anything depend on a1 and a2 value. Okay, so please understand your problem statement. If given problem statement by a1 equal a2 is 1, then this is omit. If problem give you a1 is and a2 equal half, so you must use half equation. Okay, you must use half. Using your module, please highlight this equation. Okay, using module, please highlight this equation. If you use textbook, please highlight this equation for second order branch kata. Okay, for second order range kata. However, you must calculate K1 value. K1 value is fxiyi. K2 value is equal function xi plus h, yi plus k1h. Okay, you must simplify this one to become one coordinate and this also. Okay, one coordinate. And then range kata second order, if A2 is 2 over 3 and then A1 1 over 3. Okay, if A1 1 over 3 and A2 2 over 3, then our general equation for second order range kata we call as Ruston method. Yi plus 1 is equal yi plus 1 over 3 k1 plus 2 over 3 k2 multiply h. Okay, so it depends on the value of A1 and A2. If A1 and A2 equal to 1, we only call second order range kata. If A1 and A2 equal to half, we call as Hune method. If A1 is equal 1 over 3 and A2 2 over 3, we call as Ruston method. The Ruston method. However, we need to calculate K1. So the formula for K1 is equal K1 equal function xiyi. K2 is equal function xi plus k plus 3 over 4 h. Okay, yi plus 3 over 4 k1. So please check in your module and then highlight all those equations. Okay, purposely you need to use during test 2. Okay, now let's see the example number 2, Hune method. How can we feel? We can use Hune method. He Kai Wong. He Kai Wong. Rosha. Rosha. Teh Bai Hong. Boon Ji Shin. Teh Bai Hong.
Yes, madam.
Okay. Okay. So now this example 2 is use Hune method. Can you give me the equation for Hune method? Hune method in general.
The general method y equal to yi plus a1 k1 plus a2 k2 times h.
Yi plus plus tak dengar.
A1 k1
What is the value A1 for Hune method?
one over 2
K1 plus
1 over 2 k2
multiply.
h.
Okay, what is the formula for K1?
And fxy is it?
K2 formula.
Ini tak berapa ingat lah madam.
Hey, you don't have your module? You have your
Not with
module?
me now. Yeah, but
Huh?
not with me now. Sorry, madam.
No? You don't have your own module or textbook? How can you want to prepare for test 2? Huh? Not everyone have module or textbook. Sakti? Of course, I can show your method. Yeah. I just want you to know which one. K1H. Okay? Please prepare your module or textbook. When sitting my class, you need to familiar your module or your textbook because during tests, okay, you don't have enough time to check where is the location to find all the equation. Okay? Rosha. Okay, Rosha. Your equation in chat is wrong. Please check. Please check, Rosha. Y and X cannot mix. You have comma there. Xi plus H, comma, Yi plus K1H. Okay, Rosha? Okay, hopefully you know how to differentiate X and Y value. Okay, so how can we solve this example 2? Okay, what is this value? Dy dx. Yan Zinji. Yan Zinji.
Yes, madam.
Okay. Dy over dx equal 4 exponent power 0.8 x minus 0.5y. What is this value? Where we can substitute?
FSY.
Fxy. It means that you can determine k1 value, right?
Yeah.
Okay. And then what is the value from x equals 0 to x equal 4? What is that value?
Step value. Step value is 1.
Pardon?
Step value, right?
Okay, step value is
1.
Okay, so how can we write for initial condition?
Initial condition is y bracket is not equal to 2.
Okay, good. Good. Yeah. Okay, you must transform it first. Okay, you must transform. Then you understand it's from 0 to 4. Okay, so you only need to do 4 times because step size is 1. Okay, 0, 1, 2, 3, 4. So 4, only 4 times. Okay, so you just need to repeat same as you do as Euler method, but the difference only for Huynh method, it means that Ranskata method, so you must determine K value first. K value first. Okay, so you start with X is 0, okay, Y is 2. So you masuk kat sini. X is 0, Y 2. So you dapat first K1. Tengok ni lah. Okay. So you may check this solution, yeah. Solve at initial point. Tengok ni. So here is at 0, y 2. So you masuk dulu lah. 4 exponent 0 minus 0.52. Ni dekat sini given equation. So 3. So 3 is actually initial. Okay, at initial condition. And then you repeat. Okay, repeat. This one. 4, 1. And then produce K2. Okay, K2. So at 0, H1, 1. So 0 plus 1, 1. So K2 must be for the function 0 plus 1. Okay, this is coordinate, yeah. yi. So 2. 2 plus 2 plus K1. What is the value for K1? K1 is 3. 3 multiply 1. So this solution is 5. Okay, 5. So this one 5. Okay, you kena perhatikan betul-betul 5. After that, replace function x1, y5 here. Okay, then you obtain K2. So K2 is equal for exponent 0.8, 1, okay, minus 0.5, 5. So K2, okay, determine K2. Okay, after you know the value K1 and K2, and then baru you masuk kat sini. Then you obtain Y1. Okay, at 0, Y1, so you produce Y2. Okay, Y2 is equal Y1 or Y naught lah. Okay. First of all, you need to calculate Y1, this one, equal Y naught. Okay, so plus ni, selesaikan dalam ni. 1 over 2 kali K1 plus 1 over 2 kali K2 and then kali 1. Okay, so that one then you can produce Y1. So you dapatlah ini. This is the value Y1. 6.40216. Okay, tengok yang ini ni yang saya cakap. Nilai X sama dengan 1. Ini nilai Y sama dengan 5. So this one X1, Y5. Okay. So you repeat that process. Okay, you repeat. So Y1 you adalah 6.701082. Repeat it again. Okay, after you repeat for X0, X1, 2, 3, 4, Y, and then you can obtain Y Hyun. So all the values for Y Hyun, and then for Y2, you need to use integration. Ni integration macam biasa ya, calculus. So you produce all the value compare. So how can you produce the error? Y2 minus Y approximate divide Y2. Okay, that's it for Hyun method. So you need to do it one by one, okay, to avoid confusing. Is it okay? After that, branch kata third order. So the same method for other branch kata 1, 2. Okay, however, for third order branch kata, we need to have K3. Branch kata first order, we need to have only K1. Branch kata second order, we need to have K1 and K2. Okay, branch kata third order, we need to have K1, K2, and K3. K1, okay, K1 is equal function given to us. K2 is equal function xi plus p1h, y1 plus q11, k1h. K3 lebih panjang, function xi plus p2h, yi plus q2i, q1, k1h plus q22, k2h. So for this equation, okay, the question always give or mention what is the value for P1, Q11, P2 and Q21. Don't panic. So we will give the value. If P1 equal Q1, so this is only 1. If P2 equal Q21, only 1, so you just can put 1. Okay, simplified version. And then when they derive for the third order range kata, so in general, the third order range kata, the equation is yi plus 1 equal yi plus 1 over 6 multiply k1 plus 4 k2 plus k3 multiply h. Okay, where k1 is the function xi yi, k2 is the function xi plus half h, yi plus half h k1. K3 is equal function xi plus h, yi minus h, k1 plus 2h, k2. Okay, don't memorize. Please highlight in your module or textbook. Okay, highlight in module or textbook. Please familiarize all those equations, because for test 2, the question not too hard, it's easy, but you need to know how to use all equations. Okay, the difficulty to use all the equation, it may trap you to not able to answer the question. Okay, carefully. You need to know how to use all equation. Okay. So this is the last order for Range Kata that I need to teach you. So this is fourth order Range Kata. In general, after they derive, the equation is yi plus 1 equal yi plus 1 over 6 multiply k1 plus 2k2 plus 2k3 plus k4 multiply h. So they also have specific k1 value, k2, k3, k4. You just need to apply this equation same as what we have done for example 2, second order Range Kata. Okay, so you may test slowly if given this equation. Okay, if we given this question, and then the step size h equal to 0.5, and then the initial equation y equal to 1 at x equal to 0. So it means that the initial condition that we need to write is 1. Okay, and then we do it same as Euler. We need to do repeat process. So at x equal to 0, at x equal to 0, it means that this is initial. So all of you must calculate all the k's value first. Okay, calculate all the k value. Okay, calculate all k's value. Okay, all k value. That is a procedure. So calculate k1 at x equals 0, and then you have k1 value, k2 value, k3, and k4. After you produce all k1, k2, k4, so please return to the equation for fourth order Range Kata. This is the equation. So insert all the k value and then solve for the y1. Okay, solve for y1 iteration. So y1 iteration is h 0.5. So it's at point 0.5. So please put y at 0.5. All value is 1 because this is 1. And then plus 1 over 6. Insert all the k values. So this is the k values number 1. This is k values number 2. This is k values number 3. And this is k values number 4. Only directly multiply with h, and then you will produce your y at stage 1. It means that at x equal to 0.5. Okay, so you must repeat this process. Okay, you must repeat this process by using x equal 1. This one. Okay, when x equal to 0.5, they have their own k values. Calculate it back k values, and then do calculation for x equal 1. Don't jump. You must follow step by step. Okay, step by step. That is the reason why, okay, we always use computerization for Range Kata, because this is very long process to iterate. Okay. Okay, that's it. This is only IVP. Okay, ODE IVP. Any question? Any question? Any question? Okay, usually during test 2, okay, student will receive general problem for IVP, ODE, IVP, and ODE, VVP. The question not mentioned this is for IVP. The question not mentioned this is a BVP. So when student read the problem statement, so you must understand that this is IVP. When you identify this question is IVP, so in your mind, you need to solve based on two methods, Euler or Range-Kata. You may choose Euler or Range-Kata. Okay, if you identify this question is BVP, then you must solve using BVP. Okay, so you must know this term lah. Initial, okay, initial, boundary problem and boundary value problem. Okay, any question? Any question? Okay, hopefully you understand. Okay, very simple topic. Ada? Any question? Any question?
When is test 2, Doctor?
Ada. Okay, so no question. Later I will share.
Doctor,
Ya.
saya nak tanya test 2 bila?
Okay, we confirm on 17th of June. So by next week, I will touch boundary value problem. This week, initial value problem.
Thank you,
Okay.
Doctor.
Welcome. Okay, any question related initial value problem? So after this, turn on your module. Do it all example in module. If you don't have module, turn on any e-learn e-version textbook. Do it all example for initial value problem. The process only repetition process. You need to understand what is the general equation for Euler, what is the general equation for Range-Kata, one order, second order, third order, and fourth order. After you understand how can you use all equation, and then it will make your life easy. Okay, then you try to use maybe Excel or MATLAB to solve the repetition of solution. Okay, it's up to you lah. Okay, ada lagi? Be careful yang dekat sini. Okay, yang dekat sini you kena be careful. Okay, this is the slope. Slope. Slope is function xi, yi, that is dy, dx. Ini student selalu salah. Okay. Only that. So the question always want you to compare with the true value. You must calculate approximate value, Euler or Range-Kata, and then you produce y true value. Okay, any question? No? If no, I would like to share you about the project number 2. Okay, project number 2. Can you see? PDF file. Can you see? Okay, it actually project number 2 in my section. Okay, project number 2 in my section. Okay. So I hope everybody have your own couple. Semua dah ada? Semua dah ada? Siapa tak ada member, tolong asking in group. Okay, to make sure that after I finish today, so you can start this project. Okay. So the problem statement for this project. The determination of the fundamental natural frequency for cantilever beam is crucial in many engineering applications. Here, cantilever beam refers to beam that is fixed on one end fixed. Ya, kat sini fixed ya. Here fixed and free on the other end. So this is a free. Okay, free. Generally, a cantilever beam will have an infinite number of natural frequencies corresponding to its vibration modes. However, the fundamental natural frequency refers to the natural frequency of the beam under its first vibration mode. For thin beams, the Euler-Bernoulli beam theory can be used to determine the natural frequency. The fundamental natural frequency of the cantilever beam is determined by the following equation. So ingat, this is the natural frequency. Okay, this is the natural frequency. Okay, where the natural frequency is the fundamental natural frequency of the beam in hertz. E is the beam Young modulus. Okay, E Young modulus. T is the thickness of the beam. Rho is the beam density. L is the length of the beam, and the beta 1 is the fundamental eigenfrequency of the beam, which can be determined as the smallest absolute value from the characteristic equation of the polymeric equation 2. Okay, and corresponding to the vibration mode number. Okay, this one. Okay, and corresponding to vibration mode number is any kind of number. B is, okay, B is fundamental eigenfrequency. Your task, based on this problem, cantilever beam. So given that the eigenvalue for metric B, this one, metric B in equation 2 is lambda equal cons beta n. Okay, so you must rearrange this A matrix to show that lambda equal minus cos beta n. Okay, minus cos beta n. Okay, derive the characteristic equation of matrix A. This one, how can you produce this characteristic? So as we know, to determine the characteristic equation, so you must multiply this one and then minus multiply this value. Okay, so you must produce characteristic from matrix A in equation 2. Show all your working when deriving the characteristic equation. So the keyword is characteristic equation based on eigenvalue topic. Okay, eigenvalue topic. Okay, because this is lambda. Okay. Okay, after that you can change this one to lambda. And the second question, it is possible to solve for beta analytically. So you need to answer yes or not. If yes, solve it. If no, suggest another method to use to solve Bn. Okay, you need to check if Bn is slightly same as theta, cos theta. So if cos theta, how can we determine theta? So this question number 2. Okay, and then task number 2. Based on the characteristic equation derived from question 1, okay, suggest 4 methods you can use to solve for beta numerically. Among the 4 methods you have suggested, are there any method that may be less favorable to use? If yes, explain why. So this is maybe you need to check, okay, some idea using textbook, okay, internet searching and so on. Please explain in detail. Second question, select a numerical method to solve for beta n and explain in detail and in your own words all the steps required to implement the choice, okay, method for this problem. Do not calculate, okay, for this question. You just need to select what kind of numerical method. So for this one, suggest for method. Okay, and then when you suggest for method, you need to choose what is the method that less favorable. If yes, explain. This is mention about the method. And this one, choose from these four methods that you think less favorable, that is a numerical method. Okay, please inform what kind of numerical method that you choose to solve this problem. Don't calculate yet. Okay. And the question also asks you to explain in detail in your word all the steps required to implement. So it means that this is same like Sudoku. Same like how can you solve using flowchart. Okay, flowchart. Okay, task number 3. Using only MATLAB or Octave, but I suggest you to use Octave because this is the open version solver, okay, as your programming platform. Explain the algorithm you will apply in your computational, okay, programming platform to implement the chosen numerical method from question 2. No code is required for this equation. So this is only explain about your algorithm, what kind of algorithm that you need to use, and so on. Okay, don't solve the code yet. Develop your flowchart based on your algorithm and explain the flowchart. Okay, you may refer your SEM SKMM 1013 for the programming style. And then given that, okay, given the E value, T value, row value, L value, develop the single strip of code in your programming platform to solve beta and calculate the fundamental natural frequency omega 1 in hertz to 4 decimal places. Okay, find your initial gas, use any value between 0 to 2. Okay, for your stopping criterion, please make sure that your eta is less than 0.01. Please fully comment your code and display the output of your code in table form as shown in lecture. Okay. Paste your code inside the report. You may use put as appendix. Okay, appendix. Do not screenshot your code for the report. Okay, please make sure you copy and put as the appendix. Make sure that your code reflect the flowchart algorithm and step that you have given. Based on the question in 3, discuss on a method to verify your result. Okay, and then explain what you learn from the chosen method in question 2. What improve can be made in question 3 to increase the accuracy of your result. So very detailed marks. Okay, very detailed marks. So 10, 4, 14. Okay, 14, 18, 20. 20. Okay, 20, 20, all the total 20 marks. Make sure in your group project, you need to have 2 members. Okay, your report must be proper based on the UJM thesis format. It must have project grading sheet that I sent to you for the project number 1. And then front cover after the project grading sheet, which should be include the submission date, name, metric number, postcode, and so on. Introduction and problem statement, table of content, content conclusion, and bibliography. Okay, if you can insert the answer for the given task in any of the component above which is deemed suitable. A grading rubric is provided to you for your own reference as a guide in answering the given question. Okay, so everyone knows the rubric. Everyone knows how can put the project sequence. Okay, and then I hope you can put properly. And please submit the project number 2 on today is 2nd June 2021. So submission, okay, to July 2021. 1 month I gave you. Okay, you must hand over your e-report submission, okay, in e-learning, and I will open the submission link for project 2, okay, for 1 month. Okay, don't delay. Okay, don't delay and make sure that you submit on to July. Then you will have final on 4th July up to the end of July. Okay, that's it. This is your project. I will upload in e-learning and then you may start from today. Okay, for this, for the IVP project, so I don't have assignment. So make sure you start with the project. Okay, and for IVP also, you must try all the example in module and any kind of example using e-textbooks. Okay, if you don't have what we call reference e-version textbook, please prepare before you sit for the test. Please prepare. Please prepare. If not, you're not familiar what kind of equation that you need to use for the problem, okay, for the specific problem. Okay, any question? Any question? I think this project not too hard, so make sure that this is a project number 2. Okay, project number 2. Project number 2. Ada soalan? For numerical method, please make sure that the theory only little, but the exercise must be full effort. You must do by yourself. During your try to understand all the theory, if you really not understand, please let me know. Please let me know. Okay? Please let me know. Don't ignore. If you ignore, then you actually not understand. Any question? Any question? So from now, you need to start your project. So you have your SLT time. Okay, you need to have more time to complete all the project and assignment. Okay, the theory only little, sikit saja teori dia. Okay, if you don't have any question, I think better I need to stop because if I run long time for the lecture, so it will take your data, right? Your internet data. Okay, so please, if you don't really understand, personally message me and ask, yeah? Okay, so I hope you don't have any question. So we stop today. Okay, please let me know if you have problem. Okay, Assalamualaikum dan jumpa lagi.
Thank you,
Thank you,
Doctor.
Thank you, Doctor.
Yes, I will update e-learning, yeah? Thank you.
Okay, Doctor.